Hello everyone, my name is Pablo Folch. I'm a PhD candidate in the 2020 cohort and I am based at Imperial College, London. I know what you're all thinking. I am not here to talk about delicious pastries. Instead, I am here to talk about the annoying thing you have to decline every time you go into a new website. So I hope you'll be pleasantly surprised to know that I will be talking about baking. A few years ago, Google attempted to create the world's best cookie with the help of artificial intelligence. They use a technique called the Bayesian optimization. So what exactly is Bayesian optimization? Bayesian optimization is an area of machine learning that seeks to efficiently optimize expensive black box functions. A black box function is one where you only know the input and the output. This contrasts with traditional optimization methods because we cannot use gradient information at all. What we do instead is query the function at different locations. This is represented by the animation. We can think of the x-axis as consisting of different recipes. We are trying to maximize the flavor, so we're trying to find the recipe that gives us the best flavor. Now, since baking a batch of cookies is expensive because it takes a long time, we want to try to get the maximum flavor with as little queries as possible. So how can we go on about this? Bayesian optimization proposes fitting a probabilistic model to our data points. Usually we use a model called a Gaussian process. This represents our belief and our certainty on how the black box function looks. For example, looking at the plot below, our belief is represented by the blue line and the uncertainty by the shaded area. We have low uncertainty close to the recipes we have already baked, and we can use this information to choose the next recipe. For example, we can choose the recipe with the largest uncertainty. So what was Google's procedure when developing the cookie? Well, they would first bake a recipe, which they would then give to a lot of tasters, over 100 people. Each taster would then give the cookie a score, let's say between 0 and 10, and then all scores would be aggregated, and this information would then be used to update the model. And then the updated model would be used to select a new recipe. We can do this cycle as many times as we want until we have a satisfactory cookie. But an important question then pops up. Can we make this process faster? In my research, I propose a method which combines multi-fidelity and batch methods. Multi-fidelity refers to the process of using cheap approximations to the objective function. This allows us to explore the search space and recognize promising areas without using all our resources. So, for example, let's say that instead of giving the cookie to all 100 tasters, we could use a small subsample and instead give it to 10 randomly selected tasters. Batch methods refer to the process of choosing multiple query points at the same time. This can help us be more efficient because we are able to bake multiple recipes simultaneously. At this point, you're probably wondering, well, cookies are nice and all, but how can this actually help us? Well, experimental evidence shows that combining both methods can lead to significant speedups for finding better recipes. But this has applications far beyond baking. In particular, I was inspired by laboratory chemistry. It could be useful to find solutions to very important issues. For example, how can we reduce waste when manufacturing? Or maybe we can manufacture medicines more efficiently. However, these are just a few examples, and the number of potential applications is almost endless. I am looking forward to continue to work on this vein of research and see where it leads. Finally, I would like to thank you for your attention. If you have any questions or are interested in discussing this further, feel free to email me to the address displayed on the screen. I will also leave some references to Bayesian optimization and Google's research in the description. I hope you found this presentation interesting and it gave you a little flavor of what makes me excited about my work.